Alright, ladies and gents, what we're going to do today is the section 7.3 day 2. We're going to work with the composition of functions. It's going to be a new operation than what we've done in the past, but it shouldn't be anything too wild. It's combining a lot of the different skills that we've used before. Just structurally it'll be a little different. So to start, let's get into our warm-up. Pause the video as always and go through and do this. Alright, hopefully you guys actually do this. Alright, so here are our answers to the do now. For part A, with the product, we have 8x to the 8/3, and for part B, we have x to the 4/3 over 2. Now, quickly, if we take a look at A and B, A is relatively straightforward. Come on, Mr. Clark. Guest appearance. You want to pop on and explain some composition of functions?
No, I'm good.
You good? You sure?
Yeah.
Whatever you say. Alright, so back to your regularly scheduled program. Taking a look at this. So when we look at our product, we're looking at our constants. We're multiplying those two together, which gave us the 8, and then we're multiplying two things of the same base. We need a common denominator because we're adding our exponents, and that's what we did throughout the problem. In part B, we are dividing two things of the same base. We divide the 2 and the 4, which gives us the 1 over 2, and then we're dividing two things of the same base, so we should be subtracting those exponents, and that brings us through the rest of this. You guys probably knocked that out of the park. So what we're going to work on today is called the composition of functions. Okay, basically what we're going to do is we're going to take one function and insert it into another function. When you look at what it means to compose something in terms of math, it's when we take some function and it's made up of other existing functions. So if we think about what f of 3 means, given that our function f of x is equal to x plus 1. What this means is we're taking 3 and we're plugging that in for x. So we would have 3 plus 1. Now if I said that my function, what I wanted to plug in was x minus 2, you'd literally follow the same exact steps, but instead of plugging in 3, what I'm going to do is I'm going to plug in x minus 2 anywhere I see an x. So I would say x minus 2 plus 1. Just like I did with the 3, literally the same exact step, and I can simplify that. It'll just be x minus 1. That's what composition of functions are going to be, and we're going to go through a bunch of examples on that. So taking a look at this first one, f of x is 3x, and g of x is 2x minus 1. So the first step, what it's saying is f of g of x. That's how this is going to be read. We go outside in. So f of g of x. Basically what we're going to do is we're going to start with f. G of x is defined as 2x minus 1 in the example up here. So what that means is we're going to take 2x minus 1 and we're going to plug it in for x on the function f of x. So when we do that, instead of writing 3x, we're going to write 3, and this is going to get plugged in for x, 2x minus 1. Now from here, this is something that we've done plenty. We distribute the 3, we'd have 6x minus 3. That would be the composition of the two functions. It kind of combines a bunch of different operations. Now if we went the other way, if we said g of f of x, we would take g, we're going to plug in f, which is defined as 3x. Now we're going to look at function g, and we're going to take 3x, plug that in for x here. So we would have 2 times 3x minus 1. 2 times 3x to give us 6x minus 1. And that would be everything simplified all the way through. So again, you're taking one function and you're substituting it into another function. Alright, we'll do it again. Same idea. Now f of x is defined as 4x squared. G of x is defined as 2x cubed. So, looking at this, we'll start with g of x. Peace out, Mr. Clark.
Ooh, see you, Mr. Hain.
So, like I said, back to our regularly scheduled program. F of g of x. So we're going to take g of x and we're going to substitute that in here. That would be 2x cubed. Okay. Then we're going to plug that 2x cubed in for x in this function. So we would have 4 times 2x cubed squared. Okay. And now from here, what this becomes is like every problem that we've done with these exponent properties. The 2 has to get distributed to both things. I would have 4 times 2 squared times x to the 6th because we're multiplying exponents here. We would have 4 times 4 x to the 6th. That would give us 16x to the 6th Okay, we'll get into that example next. Alright, again, you took g of x, you substituted it in for this, 2x cubed, and now we're taking that and we're plugging it into f. Same idea here, g of f of x. Let's start with what f of x is. F of x is 4x squared, and I'm plugging that into the function g. When I plug it into the function g, I'm plugging it in for x. So anywhere that I see an x, I'm substituting in 4x squared. I write 2 cubed, and instead of x, I'm going to write 4x squared. Same process. 3 would have to get distributed to both in the exponent. I would have 2 times 4 cubed. Now I have x to the 6th. 4 cubed, 64. X to the 6th. Multiplying all this together will give me 128 x to the 6th. Okay? Same kind of approach. Okay? It's composing functions, taking one, substituting it into the other. F of x. We can do that as well. We're going to work f. What is f of x? 4x squared. Now I'm going to take this 4x squared and plug it in for x. I would have 4. There's an x. What am I plugging in? 4x squared. Distribute to both exponents. Times 4 squared. X to the 4th. We would have 4 times 16 x to the 4th. Will give you 64 x to the 4th. And that would be my answer. Same thing here. G of x. You're going to take, what is g of x? Well, it's 2x cubed. I'm going to take that, substitute it in anywhere I see an x. So I would say 2 cubed. Now I would have 2x cubed. The cubed gets sent to both exponents because it's a power of a power. 2 times 2 to the 3rd. Multiply the exponents because it's a power of a power. 2 times 8 x to the 9th will give you 16 x to the 9th. Okay, this process is the same thing over and over and over again. What I want you guys to do is I want you guys to try these 4. Okay, and really, like I said I'm going to do now, pause the video and really try. Okay, because I'm not going to explain them till the end. So pause it and give it a shot. Alright, taking a look at these, here are our answers that are circled. F of g of x. G of x is x plus 4, and what we're going to do with that x plus 4 is substitute it in anywhere that we see an x. So we would still write 10, and instead of writing x, we'd write x plus 4, because that's what we're substituting in. And then we just distribute it, which you guys should be comfortable with. In B, we have g of f of x. We have 10x is what we define as f of x. You're going to plug that into g, anywhere that you see an x. We see it here, so instead of writing x, I'm going to write 10x plus 4, and all I can do is simplify that down to 10x plus 4. Same idea in C and in D. Okay, you're taking this function and plugging it into f anywhere that you see an x. Taking this function, plugging it in anywhere that we see an x in G, and then just simplify all the way through. Okay? This may be confusing. What I'm going to do is I'm going to give you guys another video for this. Okay, with different examples. Maybe it'll make a little more sense. But what I want you guys to do is this is coupled with an exercise sheet. So go through, try them, see what you can do. Okay, and any questions that you have, ask me when I come back. Okay, but best of luck with this.